Welcome back, everyone. Today, we're diving into an incredibly fascinating explainer. We are looking at the absolute bleeding edge of software development, focusing on the exact blueprint for transitioning from those fragile AI wrappers we see everywhere to true enterprise-grade autonomous systems. If you've been following AI at all, you already know the hype, but today we're getting into the infrastructure. We are talking about the actual anatomy of an agentic software factory.
You know how for years the industry has practically worshipped the idea of the 10x engineer? That brilliant coder pulling all-nighters to write bespoke code from scratch? Well, we are rapidly metamorphosizing into an era of massive productivity multipliers. Welcome to the 1000x Agentic factory. The core unit of production isn't just the human developer anymore, it's human orchestration layered over autonomous agents. The fundamental shift here is that generative models are graduating from being junior implementers to principal engineers, meaning human developers are shifting from actively writing code to rigorously verifying systems.
In this new building block economy, true scalability doesn't come from brute forcing huge monolithic applications. Instead, autonomous agents absolutely thrive on stitching together proven primitives. We're talking about things like robust message queues, Postgres databases, and standardized APIs. When the marginal cost of code generation approaches zero, human taste, creativity, and judgment become your ultimate competitive moats.
So here is our roadmap for today. 1. The 1000x Agentic factory. 2. The 12-factor agent. 3. Architecture, brains and skills. 4. Memory and sensorium. 5. The Skillify protocol. And finally, 6. Security, the human verifier.
All right, let's jump right into Section 1, the 1000x Agentic factory.
So why the huge paradigm shift? It really comes down to this number right here, 70%. That is the absolute reliability ceiling of your basic prompt plus a bag of tools integration. While those setups make for absolutely jaw-dropping demos on social media, they are wholly inadequate for customer-facing enterprise software. If you're deploying working code with tight permissions, you just cannot tolerate a system that fails 2 or 3 times out of 10. We have to completely eliminate hallucinations and entropy.
That brings us to Section 2, the 12-factor agent.
To get past that ceiling, let's rapid fire through the core rules. First, you have to strictly separate reasoning from action by having agents parse natural language directly into structured tool calls. Second, own your prompts. You've got to treat them as version-controlled code, never outsource them to some black box framework. Third, engineer your own custom context windows to prevent token bloat. And fourth, unify your execution and business history into a single ledger so debugging becomes trivial.
Building on those factors, you absolutely have to own your control flow. Your execution loops must be able to pause securely. Think about it. If a model hits a highly ambiguous or potentially destructive operation, the loop needs to break immediately, mandating an asynchronous human webhook for approval. The system safely routes low-stakes actions completely on its own, but guarantees human oversight exactly when it matters most.
Moving on to Section 3, Architecture, Brains and Skills.
Listen, a massive vulnerability we see in legacy agent design is mixing up how an agent works with what your organization actually knows. If you decide to change your agent framework down the line, you definitely don't want to lose all your institutional knowledge. The strict boundary works like this. The agent repository dictates how the agent operates. It holds the skills and tasks, but absolutely no factual data. The brain repository stores what is known, the immutable world knowledge and dossiers. You've got to keep them physically separated.
Within that operational side, we lean into this thin harness, fat skills philosophy. Heavy, 20,000-line monolithic system prompts are just a nightmare that cause severe token latency and exponential hallucinations. Instead, you want to use an incredibly thin harness purely for routing and safety. All the actual intelligence and judgment is pushed up into fat skills. These are markdown files that we treat as executable recipes. They act like a method call that beautifully combines architecture and logic into one reusable capability.
And this brings us to a major pitfall. Let's be honest. LLMs are pretty terrible at mathematical precision or tracking complex state inside their internal latent space. So we use the deterministic collector pattern. Code for data, LLM for judgment. We let rigid Python or Node scripts mechanically gather and deduplicate data, outputting a clean digest. The LLM is invoked only to read that digest and apply its qualitative judgment. Offloading the rote data gathering entirely eradicates those nasty structural hallucinations. Okay, let's look at Section 4, Memory and Sensorium. To synthesize a persistent, compounding intellect that doesn't just forget things the next day, advanced frameworks like Gary Tan's GBrain rely on a 3-layer cognitive architecture. Layer 1 is your session context, which just manages the transient back-and-forth conversation. Layer 2 is the agent memory, functioning as an operational ledger of the agent's behavioral preferences. And Layer 3 is the world knowledge, or GBrain, a vast, graph-wired repository containing literally millions of tokens of organizational memory.
But here's the tricky part. How do you retrieve exactly what you need from that massive world knowledge repository? A standard vector search isn't going to cut it. GBrain employs hybrid search, merged together using the reciprocal rank fusion formula. Basically, it runs a deep semantic search to find contextual meaning, while simultaneously running an exact keyword search. This mathematical formula fairly balances the two, making sure the agent's context window is injected with perfectly balanced, high-signal data.
Once that perfectly balanced data is retrieved, you have to enforce strict truth-telling. We use the compiled truth and timeline pattern. It works like this. Every single claim in a synthesized executive summary above the line must link directly to the raw immutable evidence below the line. So it's essentially a continually rewritten synthesis up top, backed by a hard chronological ledger of evidence at the bottom. Having this auditable trail stops hallucination drift in its tracks. To passively grow this institutional memory, the factory utilizes closed-loop ingestion pipelines. Instead of letting valuable context vanish into disorganized Slack threads or unrecorded calls, specialized subagents are passively intercepting signals. Meeting pipelines entirely bypass hallucinated summaries to extract raw transcripts. Diligence pipelines rip through huge PDFs using OCR, and email pipelines pull timelines to create pre-formatted digests. It literally turns ambient organizational noise into a highly traversable internal graph.
Next up, Section 5, the Skillify Protocol.
This entire protocol is driven by one incredibly relentless macro rule. Are you ready? If an operator has to ask an agent to perform a specific task twice, it is a system failure. Think about that. You don't want your engineering team wasting time constantly reprompting bots. Instead, that task must immediately be codified into an automated, permanent skill and slapped onto a cron schedule.
Now, to make sure that shiny new automated skill doesn't just introduce chaos, it has to pass a rigorous 11-point audit before deployment. Let's highlight a few of the toughest quality gates. First, it requires 80 to 90% unit test coverage on all deterministic logic. But crucially, it mandates cross-modal evaluation. Relying on one single frontier model creates massive blind spots, right? So this process dispatches the output to multiple models, say Anthropic, OpenAI, and Google, and requires them to reach a consensus before anything goes live.
Finally, Section 6, Security and the Human Verifier.
At a certain point, manual pull request reviews just become completely impossible to scale. Enter autonomous red teaming, like Vercel's DeepSec architecture. This 5-stage process replaces legacy security tools with active cognitive agents. It scans for sensitive patterns, investigates the actual logic, revalidates its findings against Git history to slash false positives, enriches the data to find the responsible committer, and exports actionable tickets. And it does all of this safely inside lockdown micro-VM sandboxes to neutralize any prompt injection attacks. Operationally speaking, we also have to lock down our internal perimeters. Allowing an agent to natively hold raw API tokens is practically begging for a catastrophe. So instead, we use credential gateways. The gateway physically holds the raw tokens, while the agent is only given a task ID. When the agent attempts an action, the gateway evaluates the intent. So, if an overeager agent suddenly decides it wants to bulk delete your entire inbox, the gateway physically blocks the operation. And that wraps up our explainer for today. We've seen exactly how strict architectures, deterministic collectors, compounding memory, and autonomous security all combine to build a true 1000x agentic factory. So I want to leave you with a final provocative thought. As the marginal cost of code rapidly approaches zero, are you preparing your engineering team to be active writers or rigorous verifiers? It might just be time to rethink your infrastructure. Thanks so much for learning with me today, and I'll catch you on the next one.